algebra students, I hope you're finding yourselves well today. Nathan, I hope you're paying attention because this lesson is going to be almost as easy as the last two. Today we are solving equations with quantities in them. And I know some of you realize that, hey, I'm going to go ahead and I'm going to distribute this 2 to both quantities. And that is a very good way to do that. In fact, it is never wrong to do that. I'm going to go ahead and do that. But then I'm going to show you a second way to try this problem. It only works sometimes. I'm going to do 2 times 3x, which will be 6x. And then 2 times -5 is -10. And that'll equal 12. And then I'm going to go ahead. I just have a plain old two-step equation. I'll add 10 to each side. And I'll get 6x will equal 22. And to get the x alone, I'll divide each side by 6. And notice I'm not running to my calculator again. And if I want, I can simplify that 22/6 into 11/3. And I'll take 11/3 as a legitimate answer. But of course, you're more than welcome to turn that into a mixed number. 3 will go into 11 3 times. There'll be 2 left over. You'll be at 9, 2 short of 11. And you divide it by 3. So x could equal 11/3 or x could equal 3 2/3. You don't need both for answers. All right. Now, I promised to show you another way to do that, and I will right now. Let me pause the time. Okay, so there's the original equation. I'm going to do it a different way. You notice this 2 out front here in the quantity. How is it attached to that quantity? Well, it's multiplication, right? Because when you distributed it, you end up getting, you end up multiplying, right? Well, you notice this 12 over here? Does the 2 go into the 12 evenly? It sure does. 12 can be divided by 2. What I'm going to do to both sides is, since this 2 is attached to the quantity by multiplication, I'm going to divide by 2. But if I do it on the left-hand side, I have to do it on the right-hand side. And then I will end up with 3x minus 5, because the 2's canceled, shoop shoop, and 12 divided by 2 is 6. All right, now I have a two-step equation. I'm going to add 5 to each side, add 5 to each side, and I get 3x equals 11. Oops, I didn't write 11, did I? There we go. And then I'll divide by 3. And notice I'm going to get x equals 11/3. Now that's the same answer I got last time, and I might have gotten there a step quicker this time. Or you can tell me that x equals 3 2/3 if I convert it to a mixed number. My airliner is acting quite strange. Either answer is sufficient. You don't need both. All right, let's take a look at problem number 2. Problem number 2. That little cool shortcut I did will definitely work on this one. Oh my goodness, I thought I had my highlighter on, but I don't. Here we go. Please stop laughing at me, Sam. I'm only human. All right, so I can do that little division trick. I'm not going to, because I want to make sure you know how to do it by distributing. But if you'd like to do it by division, you go right ahead. I'm going to distribute the 3 to the entire quantity. And I'm going to go 3 times 4x, which will give me 12x. 3 times 1 is 3, and then I'll have 27. All right, I'll subtract 3 from both sides. You notice I'm not really explaining why. I'm expecting you to be an expert at solving two-step equations. Once I turn this into a two-step equation, you should have absolutely no problem solving it on your own from there. If you are having trouble, come on in and see me for help. If you don't know why I divided by 12 right there, come on in and see me for help. X will be 2. And again, if I wanted to check it, like I've done in the other videos, I could put 2 in right here for x. 4 times 2 is 8. 8 plus 1 is 9. 9 times 3, 27. Ooh, I got a nice scarlet star, just like the Buckeyes. All right, problem number 3. Again, it's going to work. I could do that little division if I wanted to. Division trick that I showed you on that first problem. Why could I do it? Because, no, I did it again, you silly Mr. Lawrence. Because -4 is attached to the quantity by multiplication, and 16 can be divided evenly by -4. But I'm going to distribute just to get it through. This is how you do it. Okay, now be very careful here. -4 times 2x is going to be -8x. -4 times -3 is going to be a +12. That'll equal 16. 16, there we go, that looks better. And I will subtract 12 from both sides. And I'll get -8x equals 4. I'll divide each side by -8. X will equal -1/2. And there we go. All right, one last problem for you. Looks a little different than the other ones. I got a question for you. Can I do my little division trick? What do you think about that? Jacob, what do you think about that? Let's see here. So there's my 5 attached by multiplication. Does 5 go into the 7 evenly? No, it does not. I could do my little division trick, but it's more likely that I'm going to make the problem uglier or more difficult to deal with. Had this been a 5 or a 10 or a 15 or some other multiple of 5, it would be a great time to do it, but in this case, it would not. All right, so I'm going to multiply 5 times 6, and I'm going to multiply 5 times -2. So I'll get 30 minus 10x, and that'll equal 7. I will have a 30 here I have to get rid of. It's a +30, so therefore it's attached to 10x by addition. I will subtract 30 from each side, minus 30. All right, I've got -10x on the left. Now before you get this wrong, do you know what 30 minus 7 is? Hopefully you know it's 23. Okay, well if it's 23, then 7 minus 30 must be -23. Okay, now x is not alone, it's got a -10 attached to it, so I'll divide by -10. And this is a situation where I might actually go ahead and use a decimal because it's going to be easier. I know my answer will be positive. 23 divided by 10 is simply 2 3/10. Or I could have written as 2 3/10 if I wanted to. Okay, if you're wondering how I did that, check this out. What's 2 times 10? Well, of course you know it's 20, right? Where was the decimal point on the 2? It was right here. But now it's right here. It moved over one place. You see that? What's 7 times 10? Well, of course you know it's 70. It's like the decimal point, which originally was here, moved behind the 70. Behind the 0. Well, 2 times 1,000. I'll bet most of you know that it's 2,000. Well, it's just like the decimal point, which was behind the 2 to start with, went 1, 2, 3. Why did it go 3? I wonder why it went 3, but on a 70, it only went 1. And on a 20, it only went 1. If I did say 9 times 10,000, how many places do you think that decimal point would move? Geez, Mr. Lawrence, this is just such a hard problem. I really don't know. 1, 2, 3, 4. $90,000. How does that work with decimals? Well, it works really cool. 2 7/500 times 10 becomes 27 5/10. The decimal point was here and it moved 1 because there's 1 0. Okay, the division goes the other way. If I had a problem like, say, 650 divided by 100, well, I'm still going to have a 6 and a 5, But the decimal point, which is here, is going to move back 2 places. And so it's going to go 1, 2, which ends up being 6 5/10. All right, that's something you really should know how to do, but if you're not sure, come on and see me. I'd love to work with you on it. All right, Mr. Lawrence signing off. Have a good night, everybody.